Hello, my name is Katherine Atkins, and I'm a senior environmental science major with a minor in data science here at the university. And today I will be discussing projecting agrohydrological outcomes using the apex rays model and various climate scenarios from global circulation models. In addition to that objective, I will also be investigating the impacts of grazing activities on grasslands and croplands under different climate scenarios. The significance of a study like this is because general climate trends predict warmer weather, and with warmer weather, you also see a change in precipitation and soil adaptability. And it's important to understand those components when improving agricultural management systems or when suggesting better land management strategies to reflect the needs of the land. This first graph I have here shows how temperature is predicted to increase before the end of the century, and I made this using global circulation models. Each global circulation model, or GCM, has two variations: an 8.5 variation, which represents business as usual practices, and a 4.5 variation, which represents incorporating climate change mitigation techniques. And we can see that the 8.5 variation does have warmer temperatures than the more middle ground 4.5 variations. For today's project, I will be using Access 1, GFDLCM3, and MEROC 5 as my GCMs. The study site for today's project is the USDA ARS Oklahoma and Central Plains Agricultural Research Center, which is located near El Reno, Oklahoma. And this study specifically focuses on watershed number 1, which we can see at the bottom of this map, which is a native prairie grassland watershed, and watershed number 8, which is a cultivated cropland watershed. And what's unique about this data is not only was it very well documented over 20 years from 1977 to 1999, but this data was also being actively grazed on throughout the entire time the data was being collected. And this is very important when figuring out how grazing might be impacted with climate change, or how grazing might change a cropland watershed versus a native prairie grassland watershed. And we can see how these things might be impacted using the Agricultural Policy and Environmental Extender model, or APEX GRAZE. This model specifically focuses on how grazing might impact a watershed, and it's very cool in how the input for the system is calibrated using land management system technique and information, and then the output is how the soil health is being impacted. To use this model, you first obtain the global circulation model data from open source IPCC website, and then concatenate that predicted data with the historical data, and then run that full data set through the apex GRAZE model. And the output is how the soil is, the soil health, or how it's predicted to change. First, let's take a look at this table right here, which shows watershed number 1 at the top and watershed number 8. Highlighted in blue is the 4.5 variation of Access 1 specifically, which is the cooler variation. And then in orange, we see the 8.5 variation, which is once again the warmer temperatures. For this, overall, we can see a general decrease in soil nutrients and soil health, a decrease with an increase of temperature. But we can also see an increase in water yield, precipitation, and evapotranspiration, but that's likely because warmer temperatures are predicted to bring more precipitation. Something of note is that nitrogen and phosphorus levels are generally lower for the native prairie grassland information with warmer temperatures. However, with warmer temperatures and the cultivated cropland data set, we can see an increase in nitrogen and a relatively consistent amount of phosphorus. Now, if we take a look at biomass production for each of these watersheds, when comparing all 3 global circulation models for each of these watersheds, we can see that with warmer data and with warmer temperatures in the watershed number 1, we can see a lower amount of biomass when compared to the cooler temperatures. However, in the cultivated cropland watershed, we can see that it's all relatively the same in both the warmer and the cooler temperatures. And this is likely because with cultivated croplands, you do see that seasonal rotation, or that more seasonality of input for the system, which is likely being shown in this model. So to conclude today's presentation of this poster, overall, information like this can be very useful when suggesting sustainable agricultural practices, or it can serve as a platform for future research. To summarize the data we saw, the preliminary projections indicate that native prairie grasslands observe lower biomass production, nitrogen, and phosphorus with warmer temperatures than in cooler temperatures. The cultivated croplands observe an increase in nitrogen with consistent phosphorus levels and biomass production for both climate scenarios. And then overall, there is a decrease in water yield, but higher level of water yield, precipitation, and evapotranspiration are observed with warmer temperatures. With that being said, thank you all very much for watching. If you have any questions, definitely do feel free to let me know. Have a great day.